What's up? I'm Vin, and today I want to show how to evaluate trig functions when you're given an angle in radians. So the first question we'll look at is we're going to find what is sine of pi over 4. Now, the thought process for these questions, the first thing I ask myself is which quadrant does the angle terminate in? So pi over 4 radians is the same thing as 45 degrees. So this is going to be a quadrant 1 angle, and in quadrant 1, all the trig functions are positive. So then I just ask myself, all right, what is sine of 45 degrees? And sine of 45 degrees, or pi over 4 radians, is square root 2 over 2. So we'll move on to another one now. Let's say next I want to find what is tangent at pi over 3. So one of the things we have to know here is that pi over 3 is the same thing as 60 degrees. So we'll just make this a little bit neater. So this is pi over 3 is 60 degrees. And once again, we are in quadrant 1. And tangent at pi over 3 is just square root 3. Now, let's say for some reason that value wasn't memorized. You could also think of this as sine of pi over 3 divided by cosine of pi over 3. So just use the identity for tangent. And then this would give you square root 3 over 2 divided by a half. And then notice here when we simplify this, the 2 over 2 will cancel, and square root 3 divided by 1 is just square root 3. So this is just a little trick for evaluating tangent if we forget the exact value. Now, let's say we want to find, let's say we'll go with cotangent of pi over 6. So once again, we are still in quadrant 1. Pi over 6 is the same thing as 30 degrees. So this is once again in quadrant 1. So this is the nicest case when you don't have something too crazy to think about. And cotangent is the same thing as 1 over tangent. So I have 1 over tangent of pi over 6. And then if you know your trig values, pi over 6 is 30 degrees, and tangent at 30 degrees is the same thing as square root 3 over 3. So then we just take the reciprocal of this. This is going to be 3 over square root 3. And we could leave our answer like this, but this actually simplifies really nice. If we multiply the top and bottom by square root 3, we have 3 square root 3 divided by 3, and now the 3's cancel, and the final answer to that last one is just going to be square root of 3. So for the next round of questions, let's up the difficulty a bit. And let's say we want to find what is cosine of 2 pi over 3. So now we're leaving quadrant 1. So the thought process is still the same. So what I ask myself is, which quadrant does 2 pi over 3 terminate in? And 2 pi over 3 is equal to 60 degrees, and then times 2 is 120 degrees. So this is going to be a quadrant 2 angle. All right, a little trick that I use, the reference angle, is usually hidden in the radian measure. So it's either going to be pi over 3, pi over 4, or pi over 6. So notice this fraction is as reduced as possible. So our reference angle here is pi over 3. So what that tells me is if I think of the quadrants, I know in the first quadrant all the trig functions are positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. So because we're terminating in quadrant 2, only sine is positive there, I know that our answer to this automatically is going to be negative. But then what I do is I look for the reference angle, and the reference angle here is pi over 3. So cosine of pi over 3, or cosine of 60 degrees, is equal to a half. So what this tells us is that our answer here is going to be negative 1/2. So once again, the first thing I look for is the quadrant, and that tells me if my answer is going to be positive or negative. And then the reference angle tells me the exact value of the trig function. So now let's look at another example. For question 5, let's say we want to find what is sine of 4 pi over 3. So now the new thought process here is we think about 4 pi over 3. And this angle, once again, has a reference angle of 60, and 60 degrees times 4 is 240 degrees. And if you think about it, 240 degrees is an angle that terminates in quadrant 3 because it's between 180 and 270 degrees. So right away, I know that this answer is coming out negative. And from here, what we have to say is, all right, what is sine of the reference angle pi over 3? And that's going to be root 3 over 2. So this solution is going to work out to negative square root 3 divided by 2. And now for the last one here, or for the last one of this section, we're going to look at tangent of 5 pi over 4. So the first thing that pops into mind here is that 5 pi over 4, my reference angle is pi over 4, or 45 degrees. And when I do 45 times 5, that's 225 degrees. So once again, I'm in quadrant 3. But no, in quadrant 3, tangent is positive. So whatever this works out to, my answer is going to be positive. And then once again, my reference angle is pi over 4. So I think, all right, tangent of pi over 4 is equal to 1. So for question 6, the solution is just going to be 1. For question 7, we'll take a look at secant of pi over 3. So for this one here, we're just going to take the reciprocal of secant, and that's going to be 1 over cosine of pi over 3. And the thought process here is we are in quadrant 1, where all the trig functions are positive. So I don't have to worry about too much. Pi over 3 corresponds to 60 degrees. So when we simplify this, this is going to be 1 over cosine of 60 degrees, or pi over 3, is equal to a half, and 1 divided by a half simplifies to 2. So there's our solution to 7. And now for question 8, we'll take a look at cosecant of pi. And now notice here, this is one of the quadrant angles. This falls directly on the 180 degree line. So this we're going to rewrite as 1 over sine of pi. And if you think about this carefully, this one we would need to know a little bit about the unit circle. But sine of pi is equal to 0. So you could know about the unit circle, or you could just draw out the graph of sine and see here that sine hits the x-axis at 0, at pi, at 2 pi, and at negative pi, negative 2 pi, and so on. So this is going to work out to 1 over 0, which is undefined. So cosecant of pi, we could say that this expression here is undefined. Okay, division by 0 is no good, so this is actually an undefined expression. And then the last one that we'll look at here is we'll take a look at cotangent of 11 pi over 6. So for this one, this got a lot going on here, but we have to think about the angle 11 pi over 6 radians. And pi over 6 is our reference angle here. And if we think about it, pi over 6 is 30 degrees, so times 11 would give us 330 degrees. So this is going to be a quadrant 4 angle. And in quadrant 4, if we draw out our quadrants again, only cosine and its reciprocal are positive in quadrant 4. So right away, I know that our answer is going to be negative. And then I just have to take cotangent of the reference angle, and cotangent of pi over 6 is the same thing as 1 over tangent of pi over 6. So if we simplify that, 1 over tangent of pi over 6 from before, we said is square root 3 over 3. So this is going to work out to negative 3 over square root 3. And if we rationalize the denominator again, this works out to negative 3 radical 3 over 3. So the final answer to the last question is just going to be negative square root 3. Okay, well, this is going to conclude this video on evaluating trig functions with radian angle measure. If this video was helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topics you want me to cover in the comments section below. And thanks for watching.